Hello guys, welcome to another video. This one is paper 3-2 of October-November 2020. This is for A-level math. Now with that being said, let's move on to question number 1. So here we have to solve the equation. So we have to find the value of x correct to 3 decimal place. So we're given that ln of 1 plus exponential minus 3x is equal to 2. Now, first thing we have to know is, what is ln? Ln is actually log to the base of e, right? Now, for example, if I have an equation which looks like this, a here equal to b. Let's say if I want to find the value of a, what would you do? You will have to send this over here. So a is equal to exponential power b. So that's the idea. We have to use that to solve this. So again, ln is log power, so log to the base of e, and that'll be 1 plus exponential minus 3x equal to 2. Now we have to think of this as your a here, and this as your b, as in this example. Now, to find a, which is 1 plus exponential minus 3x, it is going to be, we have to send this base to here. So this will become exponential power 2. Okay, so now we have to make x become the subject of formula to find the value of x. So let's put x on one side. We can send the value of 1 to the other side. So you will have this. Okay, so now, as you can see, the power here is, is minus 3x. X is on top, so we have to bring it down. Now to bring it down, we have to take ln on both sides. So ln of exponential minus 3x is equal to ln of exponential square minus 1. Now, because of laws of logarithms, for example, let's say we have ln of a power 2. This can also be written as 2 ln of a. So same example here. If I have this, I can send this one to the beginning. So you will have minus 3x, and that will give you ln of e. Okay, and that is equal to ln of exponential minus 1. Now, something you have to know here is that, what is ln of e? Ln of e is equal to log to the base of e, and we have e here. So whenever these two are the same, it will become 1. So the main idea here is, let's say you have log of a, and then a, this will give you 1. So whenever these two are the same, it will always be 1. Okay, so that's the main idea. So here, it is this, that will be 1, so you will have minus 3x is equal to ln of this value inside, and we have to find the value of x. So divide by minus 3. So let's find out what is the value for this one. So exponential square minus 1 ln of the value, and then divide by minus 3. That should be x equal to minus 0.618 correct to 3 decimal place. And that will be your question number 1. Okay, so let's move on to question number 2. So here we have to expand this function in ascending powers of x up to and including the term in x power 3. Okay, so let's proceed one by one. So as you can see, this can be written as, so let's write this again, it can be as 1 plus 6x power 1 over 3. Right. Now, to expand this, we have to use a formula. And the good news is this formula has been given to us. If you go on your list of formulas, you will see that you have this here. This is the formula we have for this one. So let me write this down for you guys. So basically, when you have 1 plus x power n, that is going to be, the first number will always be 1. That will be plus n times x plus n times n minus 1 x squared. Because it is squared, that will be 2 factorial, and plus n times n minus 1 times n minus 2 times x power 3 over because it is 3, that will be 3 factorial. Now we can stop right here because we only care about the term in x power 3 because it keeps going, but we don't need the one afterwards. So we can stop right here. Now, how can we expand this? We have just to compare the two. So now again, something very important here. We can only use this formula if this is 1. Remember this? This can only be used if this is 1. So this is okay because this is 1 here. We can use this formula. Okay, so let's do one by one by comparing. So here we have 6x. For example, here we have x. So x will be 6x. As you can see, the power n here is 1 over 3. So n will be 1 over 3. So now we just have to replace in the equation. How will be? So 1 is 1, n is 1 over 3, x is 6x, plus n is 1 over 3. 1 over 3 minus 1 is minus 2 over 3. That will be 6x power 2 over 2 factorial. And plus that will be 1 over 3 minus 2 over 3 minus 1 again, that will be minus 5 over 3. And that will be 6x power 3 over 3 factorial. Now let's simplify one by one, okay? So that will be 1 plus, so this will be plus 2x. And this one, you can do this in your head, but obviously it's always best if you use your calculator, okay? Because you don't want to be making those stupid mistakes. Times minus 2 over 3 times 36 divided by 2 factorial. That will be minus 4. So it will be minus 4 x squared. Now for this one, so 1 over 3 times minus 2 over 3 times minus 5 over 3 times 6 power 3 divided by 3 factorial. That will be plus 13 1 over 3 x power 3. Okay, so now you can expand this if you want to. So let's write this down again. So it will be 1 plus 2x minus 4x squared. And how do you expand a mixed number? You take this one, the whole number here, multiply by 3 plus 1. So 13 times 3 plus 1, that should be 40. That will be 40 over 3x power 3. So it's always, once you do a question, it's always best to double check your simplification because you don't want to be making those silly mistakes, right? For example, this one seems kind of odd. Let's check if that is right or not. So 1 over 3 times minus 2 over 3 times minus 5 over 3 times 6 power 3. It will be this, divided by 3 factorial. Okay, so that seems to be right. So this will be your answer for part 1. We have to expand this function to x power 3. That is part 1. Now let's move on to part B. So here we have to state the values of x for which the expansion is valid. Now, if in case you forget this, no worries. You can always go back to your list of formulas. You can see that for this formula, it gives you where n is rational and when this has to be less than 1. So very easy. So usually the formula is 1 plus x power n. It tells you n has to be rational. That's the first condition. Okay, and the second condition is the modulus of x has to be less than 1. That's for the formula. Now, you are trying to expand. Here you are trying to expand 1 plus 6x 1 over 3. As you can see, n is 1 over 3, so n 1 over 3 is rational, that is good. But we don't need that here. But if you observe, here we have x, here we have 6x plus 6x. So we have to write modulus of 6x has to be less than 1. Now we can just take the value of 6 outside, less than 1. So modulus of x will be 1 over 6. So this will be your answer for part B. Of course, you can rewrite this down again as x has to be between minus 1 over 6 and 1 over 6. That will be the answer for part B. So now one thing I want to explain is, let's say for example, let me write this as a side note. For example here, let's say we did not have 1, we have 2 plus 4x power 1 over 2. So in that case, you will not be able to use this formula. So you want to try to change this so you can use this formula. So the idea here, you have to express this, rewrite this in another way, so we have 1 here. So only then we can use this formula. So let's do that. So the main idea here is I can take out the value of 2. That will be 1 plus 2x. This is power half, obviously. This will be also power half. Okay, so now as you can see, this is 2 here. This is 1 here. Now we can expand this one using this formula, and then in the end multiplying by root of 2. In the end you will have to find this one. So as you can see, we can factorize the value here always to make this become 1, and then we can use the formula. But in this case, as you can see, it was 1 already. You can use the formula directly. That was just a side note in case if you have a question that does not have 1 in the place right here. Anyways, that was question number 2. Now let's move on to question number 3. We have the variables x and y satisfy this relation. We have 2 power y equal to 3 power 1 minus 2x. Now, question part 1, by taking logarithms, show that the graph of y against x is a straight line. Okay? State the exact value of the gradient of this line. So we have to take logs on both sides of this equation. Now, the main idea here is when you have a graph of y against x is a straight line. So we have learned this in O-level. A straight line, what is the equation of a straight line? It looks like y equal to mx plus c. That's the main idea. So here we have to try to express this in terms of y equal to mx plus c. So right now we have 2 power y, 3 power 1 minus 2x. We have to take, you can take log, you can choose, you can take ln, or you can take log on both sides. So here I will take ln because there's not really a preference, because if you observe in part B, they're asking you your answer in terms of ln. So you can, because of that, I will take ln. But usually both is okay for the answer in part 1. So let's do that. That will be this. We have this power 1 minus 2x. Now again, it's the same way of thinking as we have did from question number 1. So whenever you have ln 2 power y, remember the laws of logarithms say that we can always send the y to the beginning. This can be y ln of 2. The same way, here we can write y ln of 2, and that will be 1 minus 2x ln of 3. Now we can expand the brackets, so we have y here. Ln of 2, that will be 1 times this will be ln of 3 minus 2x ln of 3. So let's try to rearrange everything so it looks more like this equation. Okay, so you have y ln of 2 is minus 2x ln of 3 plus ln of 3. Okay, one more time. We can divide by ln of 2 everywhere. So you have, because you want to remove this value, right? Because you want y to be the subject, that's why you're going to be dividing by ln of 2. That will be y equal to minus 2x ln of 3 over ln of 2 plus ln of 3 over ln of 2. Now let's try to rearrange this so we have a clear idea where is the gradient. That will be minus 2 ln of 3 over ln of 2 times x plus ln of 3 over ln of 2. Now you can compare directly what will be the gradient value. This is y, this is mx plus c. So this is your gradient. So this will be your gradient. So your answer will be gradient is minus 2 ln of 3 over ln of 2. That is your answer for part A for the exact value of the gradient. Now for part B, we have to find the exact x coordinate of a point of intersection of this line that you have just found with the line, this one. So now, whenever you see intersection, cuts, or meets, you have to solve by simultaneous equation. So right now we have two equations. We have this as number 1 and this as number 2. Here we have y and here we have y. We can solve by substitution. So on one side you will have 3x equal to minus 2 ln of 3 over ln of 2 x plus ln of 3 over ln of 2. Now, to eliminate the base of ln of 2, we have to multiply by that everywhere. Ln of 2, right? So you will have 3 ln of 2 x is equal to minus 2 ln of 3 x plus ln of 3. Now we have to find the value of x as required here. So we have to make x become the subject of formula. So we send this over here, you will have 3 ln of 2 times x plus 2 ln of 3 times x is equal to ln of 3. Okay, so now we factorize the x value outside. You will have ln of, so 3, 2 here, right? Plus 2 ln of 3. That will be ln of 3. Now something we have to know as well, just like the first part, when you have, for example here, 3 ln of 2, we can rewrite this as, we can resend the power up here, that will be ln of 2 power 3. And what is 2 power 3? It is 8. So we have to use this law of logarithms again to find this value. That will be x, that will be ln of 2 power 3 will be 8, plus ln of 3 power 2 will be 9, that will be ln of 3. Now, because we have ln and ln together here on same thing on both sides, right, we can combine those two together. Something you have to know is, let's say we have ln of a plus ln of b. It can be written as ln of a, when you have plus become multiply b. We can combine them together. So same way, let's say you had ln of a, so ln of a minus ln of b. So same way, because we have ln and ln, that can be written as ln of a, because it is minus now, we have to divide by b. So this is laws of logarithms you have to know for A level. Okay, so here we have plus, we can combine them. So that will be ln of 8 multiplied by 9. What is that? That will be 72. And that will be ln of 3. So x will be ln of 3 over ln of 72. As you can see, this is just in this form where a and b are integers, which is whole numbers, and 3 and 72 are whole numbers. That will be question number 3. Now let's move on to question number 4. So we have to show the equation tan theta plus 60 degrees equal to 2 cot theta can be written in this form. So here we have to try to expand this function and see how it can be written in this form. So now, this one, it is actually given to you on your list of formula. If you observe, we can find this pretty easily. I don't think I have it on me, but I can write this down for you. Okay, it's here. So this one will be this one, as you can see. We have to use this formula. So let me write this down. So we have tan of A plus B should be giving you tan of A plus tan of B over 1 minus tan of A, tan of B. So here we just have to replace the values in this equation. So here we have tan of theta plus 60 degrees. So that will be tan of A is tan theta, tan of B is tan 60 over 1 minus tan theta and tan 60. Now what is the value of tan 60? It is an exact value, so let's check. Tan of 60 degrees, that should give you this. So usually I know what is the exact value. Usually we have to know those exact values, so that will be root 3. So let me write this down here. Tan 60 will be root 3. So basically for 30 degrees, 45, and 60, it is best if you know what is the trig values of those angles. It will help you in your questions. So if you can memorize them, great. If you cannot, no big deal. You can always use your calculator to find those values. So let's do that. That will be tan theta plus root 3 over 1 minus root 3 tan theta. Okay, so that will be on the left hand side. Now on the right hand side, we have to know something. As a side note, what is cot theta? It is 1 over tan theta, right? So now let's replace everything back in our main equation to see what happens. So on one side we have tan theta plus root 3 over 1 minus root 3 of tan theta. That is equal to 2 over tan theta. Okay, now we can cross multiply. So you will have tan square theta plus root 3 tan theta is equal to 2 minus 2 root 3 of tan theta. Okay, so now we can rearrange everything. So this will be the same here, tan square theta. So here we have root 3 tan theta. So when you send this one over here, become plus. Then plus 3 root 3 tan theta minus 2 equal to 0. Now if you observe, this is exactly what we are looking for. This is shown as required. Okay, that will be question part A. Now let's move on to part B of this question. So now you can see hence solve the equation. So whenever you see hence, it means you have to use your answer from part A, which is previous answer. Now from part A, we have realized that this became tan square theta plus 3 root 3 tan theta minus 2 equal to 0. Now if this is tough for you to work with those tan theta, you can always write this down as u. For example, I can say let u equal to tan theta. Let's see what happens. So you will have u square plus 3 root 3 u minus 2 equal to 0. Now you can see this one is a simple quadratic equation we can solve by using our formula. So here is 1, right? So this is A, this is B, this is C. Okay, so we know that u has to be minus B plus minus root of B square will be 9 times 3 minus 4 times A times C and everything divided by 2A, which is 2. Now let's simplify one by one. U will be minus 3 root 3 plus minus. So here we have 9 times 3 minus 4 times 1 times minus 2. That will be 35. So root of 35 and divide by 2. So here we have two answers, as you can see. So first one is u is equal to minus 3 root 3 plus root 35 divided by 2. Or we have u is this minus root 35 and divide by 2. So let's solve one by one. Minus 3 root 3 plus root of 35 divided by 2. That will be u is 0.35996. Or this one can be minus 3 root 3 minus root of 35 divided by 2. That will be minus 5.5 561. Okay, so this is the values of u. Again, if you go up, we are not trying to find the values of u, we're trying to find the value of theta, so we have to replace u back by tan theta. So let's do that. Right now we have tan theta is 0.35996 and tan theta is equal to minus 5.5561. Now one by one, you can see here tan is positive. So if tan is positive, what is the quadrant it lies in? It will be in the first quadrant and in the third quadrant. You have to know it is A, S, T, C. In the first quadrant, everyone is positive. In this quadrant, sin is positive. Here we have tan is positive. And this is cos. Now, because as you can see here, it is only defined for 0 and 180, which is the first and the second quadrant. So we don't need this value. We just need the first one. So theta will be what? Tan inverse of this one, 0.359. So let's find that. 0.35996, that will be, theta will be 19.8 degrees. Okay, so now the same logic, we have to draw the quadrants to understand where we are trying to find the angles. Now, this is all is positive, sine, tan, and cos. Now, tan is negative, it will have to be in the second quadrant or the fourth quadrant. But because our angle is only between 0 and 180, we don't need this one. Okay, so we only care about this quadrant. Now, as you guys know, I have a trick whenever we solve something negative. I like to say this is 180 minus x. Now, x is not my answer. X is simply tan inverse of the positive value of this. This is negative, but I will take the positive to first find x, and theta is actually equal to 180 minus x. Okay, so x will be what? Tan inverse 5.5561, that will be 79.8, but theta will be 180 minus x, that will be 100.2 degrees. So angles always right to one decimal place, so finally theta will have to be 19.8 and 100.2 degrees. Okay, so that will be your question number 4. So let's move on to question number 5. The diagram shows a curve with parametric equations x equal to tan theta and y equal to cos square theta. Okay, that is given to you. Now part 1, we have to show that the gradient of the curve is given by this. Okay, so as you guys must know by now, gradient is what? It is dy by dx. So we are trying to find dy by dx. So because it is parametric equations, we have to use the chain rule. So dy by dx is equal to what? So on top we have dy, we write dy. On the bottom we have dx, so we write dx. And they have to be connected by something. If you observe, they both have theta in the equation, so they will be connected by d theta. Okay, so let's find one by one. Let's find this one and this one. So first thing first, we have here we have dy by d theta, so y is equal to cos square theta. So dy by d theta is what? It will be, first you take the power, that will be 2 cos theta, you have to minus 1, right? That become 1 here. And then you have to multiply by d theta of the value inside, which is cos theta. That will be, so if you d by d theta of cos, that will become minus sine, so you have minus 2 cos of this and sine of this. That will be for dy by d theta. So the idea here is, for example, if you have to, let me write this down, pretty easy. So if you have to differentiate something dx with power of 2. Pretty easy. We have to first multiply by the power, and then power minus 1 will be 1. So that's the first part of that. Because of trigonometry, we also have to multiply by dx of the trig inside. So d by dx of this one. That's why we have to do this part to get this answer. This is just something you have to know when differentiating trigonometry with powers. That will be part 1 of the answer. Now we have to find d theta by dx. So let's see. So d theta by dx. But if you observe, here we have x is equal to tan theta. So which means we can first find dx by d theta. That will be sec square theta, which is 1 over cos square theta. Now we don't need dx by d theta, we need d theta by dx. So how can you make that become that? As you can see, we just have to flip this upside down, right? So same way, from here we conclude that d theta by dx has to be cos square theta over 1. So now we can replace back in our main equation, which is this one, to find the answer. So finally, dy by dx, which is the gradient, is equal to dy by d theta, which is minus 2 cos theta sin theta multiplied by d theta by dx, which is cos square theta. So that will be minus 2 sin theta and cos power 3 theta. This is exactly as required in the question. That is for part A. Now let's move on to part B of the question. So here we have to find the exact value of the x coordinate of P. Now what is P? It says the gradient of the curve has its maximum value at the point P. Now what is the gradient? It is dy by dx, right? Now the idea here is we have to think about usually what we do. For example, we are given a curve which have equation y. Now we say, okay, y has a maximum value at the point M, for example. So we are asking you to find the maximum value. So how would you do that? You would say, at maximum value, we know that dy by dx, for example, has to be 0 to find the maximum value. Now again, now we are telling you that the gradient has a maximum value now. So basically, we are saying dy by dx has a max at P. So it means that we have to differentiate that again, d2y by dx2 at 0. I hope that makes sense, right? Because usually we're given a curve, we have to find the stationary point. We say at stationary point dy by dx has to be 0. But now, given that the gradient has a maximum, so we have to differentiate the gradient at 0 to find that point. Okay, now let's proceed. So from part 1 we have realized that dy by dx is given by minus 2 sin theta cos power 3 theta. Okay, that is dy by dx. So we have to differentiate this again. As you can see, it is a product. So we have to use the product rule. So one by one, that will be d2y by dx2. So we can leave the first one by itself, minus 2 sin theta multiplied by d by d theta of the second term, and plus we can leave the second term by itself, multiplied by d theta of the first term. Okay, now let's simplify. So for this one, that will be the same thing. And this we have to do step by step. So first thing we have to multiply the power here, that will be 3 cos, we have to minus 1, that will be 2, and multiply by dx of cos of the value inside, as we have seen before, that will be minus tan theta. Now plus the same value here, we don't change. D by dx of this one, that will be minus 2 is only a multiple, same. This will become cos theta. Now we have to simplify one by one. that will become, so minus minus become plus, so 2 sine square theta times 3 cos square theta, and that will become, we have minus 2 cos power 4 theta. Now let's factorize. As you can see here we have 2 and 2, and here we have cos square, here we have cos power 4. So what is cos power 4 again? It is basically cos square times cos square. So we can factorize us outside. So you will have cos square theta, with regard 2 cos square theta, you will have remaining 3 sine square theta minus cos square theta. This is your value of d2y by dx2. Now, we know this dy by dx has a maximum point when this equal to 0. So we have to equate that to 0. So we have two possible answers. One will be 2 cos is 0, and this will be 0. Now you have to go back to your graph, to the first part of the question to see where the value of theta lies. As you can see, theta lies here. How do we find this quadrant? If you observe, we have this quadrant. This is half pi, which is how much? Half times 90. So times 180, that would be 90. So it is in the first quadrant. And minus is just the direction, that will be in the fourth quadrant. So fourth quadrant and the first quadrant, that will be where the value of theta is going to lie. Now cos, what is cos? Cos, you know that it is going to be. So let's solve them. Anyways, let's not confuse. Let's solve them and we can eliminate the values at the end of the question. So one by one here. So here you will have cos square theta is 0. Cos theta has to be 0, which means theta has to be cos inverse of 0 has to be 90 degrees, or can be, we can write down 360 minus 90, that will be 270. That will be the two values from this one. Okay, so that's the first step. Let's find the values to see what happens. Now for this one we have to rearrange, so we have 3 sin square theta is equal to cos square theta. Now whenever you have cos and sine in the same equation, I advise divide by cos square theta on both sides. You will have 3 tan square theta is equal to 1. So tan square theta has to be 1 over 3. And finally, tan theta will be plus minus 1 over root 3. Now you can have two possible answers, which is tan theta is equal to a positive value, or it can be tan theta has to be minus 1 over root 3. Let's draw the quadrants to see where our value will lie. So when tan is positive, it will be in the first quadrant or in the third quadrant. But we know that the value of theta lies in the first and the fourth, so this one we don't need. We just need the first one. Here, for example, when tan is negative, it will be in the second quadrant and the fourth quadrant. Let's see what values do we get. So we don't need this one, right? Okay, so let's see what happens. So here we have tan theta will be tan inverse of that, so 1 divided by root this tan inverse, 30 degrees, so that will be the first value, and here you will have, will be in the, so we don't need this one, it will be in the fourth quadrant, which is, let's write this down. So as I explained before, whenever we have negative values, I like to do this technique. So I like to first write, because we have to find theta, let me first find x. So theta is actually equal to 360 minus x. Now x will be the tan inverse of the positive value of this. That will be what? Let's check it out. That will be 30 degrees. Now let's see what happens. That will be, so theta has to be 360 minus 30 degrees, and that will be 30 degrees. Now, because if you observe, if you go back to the domain that we have been given, so we know this is the angle that we are trying to find. So this is 330, not 30, 330. This is a silly mistake. So 330 will be this angle here we are trying to find, but this can also be written as what? Minus 30 degrees, because it is only the direction. So usually, let me write this down. What does the 330 means? It means that from here we start, we go until here. That will be 330 in this direction. But if you go from here to here, it will be 30 degrees, but it will be in the opposite direction. So 330 can be written as this. So now, why did I take the value negative here? So pretty simple. If you go back to your graph, you can see P is actually on the negative side of the x-coordinate. So let's see. If you take the value of theta to be 30 degrees, let's see what happens. So x will be what? Tan of 30. That will be what? That will be 1 divided by root 3. I know this is the exact value, so 1 divided by root 3. But as you can see, the value of x needs to be negative and not positive. So because of that, I will have to take the value of minus 30 degrees. X will be minus 1 over root 3. As you have seen here, so this one will not be possible because, as you can see on the graph, has to be on the negative side. And here we will take this answer, but as we have seen, this can be written as minus 30. So finally, replace back this in your main equation. X has to be tan of minus 30, and this has to be exact value, which is 1 over root 3. Okay, so that will be your answer for part B of the question. Let's move on to question number 6. The complex number u is defined by this. Okay. Now, part 1 express u in the form of x plus iy, where x and y are real. So we have to simplify this. So as you may have done this many times before, we have to multiply by the conjugate of the denominator. So multiply, that will be 1 plus I and 1 plus I. We have done this many times in surds, so same thing here. Same procedures, let's do one by one. So that will be 7 times this will be 7 plus 7i, and plus I times this will be plus I squared. 10 divided by, here we have 1 minus I and 1 plus I. Now something we have to know here is that what is I squared? I squared is actually minus 1. So something we have to know to do this question. Now something here is, we can simplify this pretty fast. So this is same as 1, so A minus B times A plus B, which is equal to A squared minus B squared. So same way, this will be 1 squared minus I squared, which is 1 minus minus 1. That should be the value of 2. Okay, so same. Let's replace back in our equation. So on top we have 7 minus 1, that should be 6. 7i plus I, that will be 8i divided by 2 on the base. That will be 3 plus 4i. This is u. Okay, so that will be your question for part A. So the main point here is to multiply top and bottom by the conjugate of the denominator. Now let's move on to part B. So here we have to show on a sketch of the organ diagram the points A, B, and C, which is U, this, and this. Okay, so let's do that. So you have to use a ruler to draw the axis, but I think I don't have a ruler here. So let me try this. Okay, anyways, that will be my imaginary axis, we'll call I, YM, and this will be your real axis. Okay, so it's not perfect, you get the idea. It needs to be horizontal and vertical. This is your real axis. Okay, so the first one is A. The point A is U which is 3 plus 4i, for example. I would say 3 will be 1, 2, 3. This is 3. 4i will be somewhere over here. Okay, so for me, the point A will be, let's say here. This is your point A. Now, it doesn't need to be exact because it is only a sketch. You just have to show where it is, okay? Then we have the point B is 7 plus I, so that's 3, 4, 5, 6, 7. I should be somewhere over here. It's only a sketch, so that will be point B. And finally, for the point C, which is 1 minus I, so 1 will be, let's say here, minus I will be somewhere over here. That will be your point C. Okay, so just like that, you have shown the points A, B, and C on the Argand diagram. It is only for 2 marks, which is not too bad. Now let's move on to part C. Considering the argument of 7 plus I and 1 minus I, show that we have this equation. Okay, so now let's think, where have we seen these two values? If you go back to the first part, you will see that U is equal to this. So let's write this down. We know that U is equal to what? 7 plus I over 1 minus I. Okay. Now what is U again? U was found to be 3 plus 4i. Now, I have a question for you guys is, how do you find argument of a complex number? So for example, let's say I have z is equal to ai plus b. Right. So the argument of z will be given by what? Will be tan inverse of this value here. So this value here, just before the I, sorry, I should have written this more in this way, so it is more understandable. So let me write it down. So z will be, let's say a plus bi. I guess that is more comparable. So tan inverse of, so the number before the I will be b over this one. So this is how you find the argument of the complex number z. Now same way here, we know this is the u is 3 plus 4i is equal to 7 plus I over 1 minus I. Now as you can see, it says by considering the arguments of these two. So what if we take argument on both sides? Argument of 3 plus 4i equal to argument of 7 plus I over 1 minus I. So these are the same because they are the same complex numbers as we have seen before, right? Now, the idea here we have to use is, if you have arg of u over v, just like logarithms, it can be written as argument of u minus argument of v. So same way, we can rewrite this down again as, so argument 3 plus 4i will be argument of 7 plus I minus argument of 1 minus I. So let's solve this one by one. So this will be tan inverse, as we have seen before, should be 4 over 3 is equal to tan inverse of 1 over 7 and minus tan inverse of minus 1 over 1. Now if you solve this on your calculator, you will see this will give you minus 45 degrees, which is minus 1 over 4 pi. So let's write this down again. You will have tan inverse of 4 over 3 is equal to tan inverse 1 over 7 minus become plus 1 over 4 pi. And that will be the part C of your question, shown as required. It is question number 6. Now let's move on to question number 7. The variables x and t satisfy this equation. Now, as you can see, t is only defined for t is more than 0. Okay, it is given that x is equal to 0 when t equal to 0. So we have to use this later on to find the value of the constant of integration. So let's do one by one. So first thing first, we have to first solve the equation, obtain an expression for x in terms of t. So we have to eventually make x become the subject of formula. So let's write this down first. We have exponential 3t dx by dt equal to cos this 2x. So now we have to rewrite this down again. So we have the corresponding dx or dt in the same place as the functions, right? So for example, here what I can do is I can take this over here first. So you will have exponential 3t dx, that will be cos square 2x, and that will be dt, right? But now here we have x and we have dt, here we have t, we have dx. It is not good. So we have to make this at least go here, or this goes here. So let's do step by step. So I can first multiply, or divide by exponential 3t on both sides. So you will have 1 dx, that will be cos square 2x over 3t dx, dt. Now we can divide by cos square 2x to eliminate this value. So you will have 1 over cos square 2x by dx, and that will be 1 over exponential 3t by dt. So as you can see, this I did this very simply. I did not want to jump any step, so you guys are not confused. How did I find this to make it x, t, and t? Right, okay, so now we can simplify. So as you guys must know from indices, let's say we have 1 over a power 3. It can be written as a power minus 3. This is from the laws of indices, as a side note. Same thing here. We can send this up by making the power negative. Copy this, 2x by dx, and this will be integration of this 3t dt. Okay, so now we can find the values with minus here, one by one. So first let's find this one. So how can we find this one? So let's try to. So we have to integrate this side. So this one's pretty easy. This will give you exponential minus 3t, the same thing. And then we just have to divide by d by dx of the top value, that will be minus 3. Now how about this one? Let's have a look. Now this one actually we did not need to write this in this form, because what do we know? We know that 1 over cos square 2x is actually sec square 2x. Okay, something we know is that, for example, if you were to integrate sec square x by dx, that will be giving you tan of x. Okay, so same way, if you were to integrate, so let's write this down as sec square 2x by dx. So this will give you, first thing first, that will become tan 2x. Now because this is 2, we have to divide by 2. Okay, so let's write this down. So finally on the left hand side you will have half tan 2x equal to exponential power minus 3t over minus 3 plus c. Well, of course, now you have to find the value of c. So how do you find that? You have to go back to the information given to you. When x equal to 0, t equal to 0. So let's write this down. So we know that we have to use this to find the value of c. Replace back in your equation, what you will have? half tan of 0 is equal to exponential of 0 over this plus c. So this will be 0 here, and that will be minus 1 over 3 plus c. So you conclude that c has to be 1 over 3. Now finally, we have to rewrite this down again. We have half tan 2x, that will be minus 1 over 3 exponential minus 3t plus 1 over 3. Okay, so that is our result for integration. But now we have to remember, we have to find x in terms of t. So let's do that. So let me write this down again. So right here we have half tan 2x is equal to 1 over 3 minus 1 over 3 exponential minus 3t. So let's see what do we have. So first thing I can do is I can try to factorize those two. 1 over 2 tan 2x, so 1 over 3 will be 1 minus exponential 3t. Then I can multiply, I can send 2 over here, you will have tan 2x, that will be 2 over 3, 1 minus exponential this. So 2x will be tan inverse of 2 over 3 times this one. Okay, so finally, x has to be half of tan inverse of 2 over 3, 1 minus exponential minus 3t this value. So this will be your answer for part A, how to express x in terms of t. And let's move on to part B. State what happens to the value of x when t tends to infinity. So let's see. Here we have our main equation. So what if t goes to infinity? So here we have exponential power 3t minus 3t. So if t goes to infinity, what happens to minus 3t? It will go to minus infinity. So what happens to exponential minus 3t? Let's find out. So let's check. If you guys don't know, no big deal. Let's check the values on your calculator. Power, let's say we take a very large value, minus 9999999. What happens? It will go to the value of 0. So we just have to replace the value of 0 of this by 0 in the equation. So x will be half tan inverse of 2 over 3 of 1 minus 0. Okay, so that will be half tan inverse of 2 over 3. Okay, so let's see what value does that give you. So half tan inverse 2 over 3. So here we have to use radians. That will be 0.294. So x2 tends to a value of 0.294 as t goes to infinity. That will be your answer for part B of question 7. Okay, so now we can move on to question number 8. So with respect to O, the position vectors of A, B, and C are given to you as you can see. Now part 1, we have to show AB equal to 2CD. So first, let's find the length of AB. Okay, this is pretty easy. We just have to use our formula. So that will be, so the thing is here we don't have AB. So let's first find AB. Okay, let's do that first. AB is what? It is OB minus OA. That will be 4 minus 1, 1 minus OA, 215. That will be 4 minus 2 is 2. That should be minus 2 and minus 4. So the length will be square root, square, that will be 4, 4, and 16. That will be what? 4 plus 4 plus 16, that will be 24. So AB will be root of 24. Let's find the value of CD. So first let's find CD. That will be OD minus OC. OD is 3, 2, 3. OC is 1, 1, 2. That will be 2, 1, 1. Okay, so now we can find the length of CD. That will be square root of the first value square. That will be 4 plus 1 plus 1. Square square is 1, 1. That will be root of 6. Okay, so now we know the length of CD and the length of AB. Now, we have to show that AB is twice the length of CD. Now we have to play with this number, which is the length of AB. Now what is 24? We can write this down as 4 times 6, right? 24 is 4 times 6. Now we can write this down again as root of 4 multiplied by root of 6. Now what is root of 4? It is 2 root of 6. So now we have realized that AB can be written as 2 root of 6, which is 2 times CD. Root of 6 is CD. So this will be shown as required. That will be part A of the question. Now part B, we have to find the angle between the two directions. So here we have to use the product rule. So the dot product, so we have AB, dot product of CD is equal to magnitude of AB multiplied by magnitude of CD and cos of the angle in between. Okay, so let's first do one by one. AB has been found to be what? 2 minus 2 and minus 4 multiplied by CD, that will be given by 2, 1, 1, as we have seen from part 1, and this is root of 24 and root of 6 and cos of the angle. Let's simplify one by one. That will be 2 times 2 is 4 plus, this will be minus 2 plus minus 4, and that will be, this will be what? So this will be, this is, as we have seen, this can be written as 2 root 6. So 2 root 6 times root 6, that will be 12, cos of the angle. Let's simplify. 4 minus 2 minus 4 is minus 2, is 12 cos of theta. Cos of theta is minus 1 over 6. Theta will be cos inverse of minus 1 over 6. We can use degrees or radians, up to you. That will be 99.6 degrees. Or you can use radians, it is up to you. That will be the angle in between those two directions. That will be part B of the question. Now let's move on to part C of the question. So we have to show the line through AB, and A and B does not intersect the line through C and D. So for that we have to find the equation of the line through A and B and the line through C and D. So one by one. So first we have to understand, how does the equation of a line looks like? It will be R equal to any point on the line. So let's say any point on the line as A, for example, has to multiply by a direction, let's call it D, and times direction. So direction will be what? Direction AB, because the line goes through AB, and times a constant, let's call this T, for example. So this is how usually a line will look like, the equation will look like, right? So let's find one by one. So let's find the equation of a line AB. Okay, so any point on the line can be point A or point B. So pretty easy. That's the first thing. So the equation of line AB can be, any point can be A or B. You can choose. So as we have seen, A was given to you by 2, 1, 5. And direction of AB we have seen from part A that it was 2 minus 2 minus 4. And we can choose any constant. For example, I would choose T here for my constant. This is my equation of line AB. Now, what is the equation of line CD? Let's say R CD has to be, So any point on the line CD, we can choose C or D, either point. So as you have seen, C is 1, 1, 2, it is given to you, and multiply by direction of CD, as we have seen again from part A, it was found to be 2, 1, 1, and we have to multiply by a constant. Let's say we choose S as the constant. So these are the equation of the two lines. So now we have to show that they do not intersect. So as we have said before, whenever we have intersection, we try to solve them simultaneously. So first, let's assume they meet. That's the first thing we have to do. So if they meet, the position has to be the same, so it has to equal to each other. So on one side we will have 2, 1, 5 plus t minus 2 minus 4 is equal to 1, 1, 2, 2, 1, 1. So that's the first thing. Now we can form our equations to see what happens. So we have 2, if you expand 2 plus 2t equal to 1 plus 2s. That is my first equation, okay? And then we have 1 plus minus 2t equal to 1 plus s. That is my second equation. And finally we have the third equation, which is 5 minus 4t is equal to 2 plus s. Okay, so now we can use the first two equations to try to find the value of s and t. And then we can check using the third equation. So let's first do that. Let's first use the first equation. So here I can make s become subject of formula. So s will be given by, so this will cancel out, that'll be minus 2t. So now we can replace in our main equation. Let's see what do we have. So s will be replaced in the first equation. So you have 2t, 2 plus 2t equal to 1 plus 2s, s is minus 2t. Now we can simplify, so 2 plus 2t is 1 plus, so minus 4t. So this over here, that will be 6t, 1 minus 3 is minus 1, right? As you can see, t has to be minus 1 over 6, okay, from this equation. Now the value of s has to be minus 2 times minus 1 over 6, that will give you 1 over 3. So using the first two equations, we have realized that the value of s has to be 1 over 3, and the value of t has to be minus 1 over 6 for them to be valid. Now, does that apply to the third equation? That is our main concern now, right? So let's replace. On the left hand side, we have 5 minus 4t, t is minus 1 over 6, which is equal to what? So this is 5 minus 4t on the left hand side, so equation number 3. So we have to first find the two values and then test on the third equation, okay? So now we can check. 5 minus 4 times minus 1 over 6. This is 5, 2 over 3. Now let's check for the left hand side. We have 2 plus s. S is 1 over 3, which is 2, 1 over 3. So it is clear that the left hand side is not equal to the right hand side. So because of that, we can conclude the the two line does not meet. So conclusion, the line AB and the line CD does not meet. Okay, so the idea here is you first find the equation of the line, and then we assume they meet. So if they meet, they will have the same position, so they will be equal to each other. We assume that, and we form three equations. We use the two equations to find the value of s and t, because those two satisfy the two equations, and we use those two values to see if it is also true for the third equation. Now, as you have seen, it is not true because this value is not equal to this value. Because of that, we conclude they do not meet. There will be questions. Let's move on to question number 9. So here we have let f of x equal to this equation, this expression. Now we have to express f of x in partial fractions. So let's do that step by step. So first step is to let f of x equal to a over. So if you observe, here we have what? Here we have a linear factor, and here we have a quadratic equation, factor expression. So first thing, we have to write this over the linear factor, right? Now because this one is a quadratic factor, we have to write bx plus c over this part. Now f of x has been given to you as 7x plus 18 over this one, right? So let's write this down so we can understand what's happening. Now, so what I can do is I can send this over here. I can multiply these two by this. Let's see what happens. So here you will have, so let me actually flip this over so it can be more simple to understand. So on the left hand side, let's say we have this plus this, because we have sent this one over here already. That will be giving you a over this times this. That will give you what? A times x squared plus 4, and this will be bx plus c times 3x plus 2. Okay, so now we have this equation to solve. So from this, we are going to try to find the values of a, b, and c. Now, what I can do first is I can try to make this become 0 by taking the value of x equal to minus 2 over 3. Now, how do I know to take the value of x as this? So it is pretty simple. If you look at this here, we have 3x plus 2. So we have to equate that to 0 and find the value of x will be minus 2 over 3. So that's how you can find the value to make this become 0. If this is 0, this also will be 0. So let's replace. You have 7 times minus 2 over 3 plus 18 here on the left hand side, and that will be a. That will be 4 over 9 plus 4, and that will be 0. Let's simplify. 7 times minus 2 over 3 plus 18, that should be 13, 1 over 3. A times 4 over 9 plus 4, that will be 4, 4 over 9. So 13, 1 over 3 divided by answer, that should be 3. So we have found the value of a, that should be 3. So right now, our new equation will look something like 7x plus 18 is equal to 3, x squared plus 4 plus bx plus c, and then 3x plus 2. Okay, so now we have to try to find other ways to find b and c. So this cannot be changed to 0 because, as you can see, this will never give you a x will always be positive, so it will not become 0. So what we do here is we have to try values of x that we can use. So we can begin with let x become 0. Let's see what happens. So you will have 18 here is equal to 3 times 4. That will be c, and that will be 2. Okay, so because this will be 0, c, and this is 0, 2. So that will be 18 is 12 plus 2c. 2c will be 6, and c will be 3. Okay, now let's rewrite down our new equation. So right now, what do we have? We have 7x plus 18 is equal to 3, x squared plus 4 plus bx plus 3. That'll be 3x plus 2. Okay, so now we have to, let's try another value so we can find b. If you try x equal to 1, so let's see what happens. We'll have 25 is equal to 3, that will be 5. That will be b plus 3 is equal to 5. So you will have 25 is equal to 15 plus 5b plus 3. Okay, so if you observe, let's see what happens. If you send this over here, you will have 25 minus 15, that will be 10. That will be 5, b plus 3, b plus 3, that will be 2, and b will be minus 1. So finally, we have seen that the value of a has to be 3, the value of b has to be minus 1, and c has to be 3. So we conclude that f of x in terms of partial fraction has to be, so we have a is 3 over 3x plus 2, and then we have bx, which is minus x plus 3 over the value of x squared plus 4. Okay, so let me double check the value of c here to see if that is right. So when x equal to 0, that will be what? 0, 18, 0, 4, 0, c, 0, 2. That seems to be fine. That will be my equation in terms of partial fraction. That is part A of the question. Now let's move on to part B of the question. Hence, we have to find the exact value of integration of f of x. So let's write this down first. Integration of f of x is now 3 over 3x plus 2. Then we have minus x plus 2, sorry, 3 over x squared plus 4 by dx. Now we can break this down into a few parts to make it easier for us. For example, I can write this down again as 2, 0. And then the first one will remain the same, which is 3x plus 2. And here we have minus, so minus x over x squared plus 4. And here we have plus 3 over x squared plus 4. Okay, so that is the same thing, but just broken down into simpler pieces that we can solve one by one. As you can see, let's do this one by one. So for the first one here, it is pretty simple. We have 3. 3 is only a multiple. You can take 3 outside. And we take ln of the denominator. That will be 3x plus 2. Now because we have 3 here, we have to divide by 3. So this will be cancelled. So you will have ln of 3x plus 2 for this one. Now how about this one? So here we have, so what's going to happen here? So usually I know it will be pretty simple directly. I can write the answer directly, but I want to explain how do we find this. So if you observe, here we have integration of 2, 0, x over x squared plus 4. As you can see here, we have x squared and here we have x. So if you differentiate this value here, you will have something in x, so you will be cancelled out, which means we can solve this by substitution. So let me show you guys how do we do this. So I just wanted to explain piece by piece, but this can be done way faster as well. But let me explain piece by piece. So let u equal to the denominator because it is in terms of x squared. So du by dx will be what? That will be 2x. So let's make dx become the subject. You will have du over 2x. Replace back in the main equation, you will have, so let's leave it as this for now. So let's leave the limits as is for now. You will have x on top. On the base you will have u, and dx is du over 2x. Okay, so let's cancel out x here, goes away. So you have integration of 2, 0 of half u by du. Now let's take out half. You will have half will be outside. Integration of 2, 0. Now what is u? So sorry, what is 1 over u? Let's write this down. What is this? This is pretty simple. It will be 1 over 2 ln of u. The limits will, so usually because we have changed the value of x, for now we have to change also the limits, but anyways we're going to revert it back. So let's leave this for now as this, because we are going to revert u back to x. That's why we can just leave it as this value. So let's do that. That will be what? Ln of x will be, so u will be x squared plus 4 of 2 and 0. So now we can first find the value. Let's see what happens. So have 2, that will be ln of 8 minus ln of 4, which is half ln of 2. So we realize that this one became half ln of 2. So we can also simplify this one if you want to. So let's do that. So what is the limits for ln of 3x plus 2 between the values of 2 and 0? That will be what? That will be ln of 3 times 2 is 6 plus 2 is 8 minus ln of 2, that will be ln of 4. So this is ln of 4. Now the last one. So this will be, you have to use your list of formulas for this one because it is quite complex to do by itself. So you will have 2, 0, 3 over x squared plus 4 by dx. Now, according to your list of formulas, you will have something like this. Let me just write this down for now. So you will have, if you integrate 1 over x squared plus a squared by dx, it is going to give you 1 over a tan inverse of x over a. This is on your list of formulas that is given to you. Now, if you observe, we have to try to match this as close as this one. We have to try to make it comparable. So what is a here? As you can see, a will have to be what? So a squared can be, here we have 4. 4 can be written as 2 squared. So we conclude that a has to be 2. So now we just have to replace back in the formula. So this, we can take out the value of 3 outside. For now, you will have 1 over x squared plus 2 squared by dx, which will give you 1, so 3 here, that will be 3, over a is 2, and tan inverse of x over a, which is 2. Now this is your answer. Limit will be 2, 0. So let's simplify this. So you will have what? 3 over 2 tan inverse of 1 minus 3 over 2 tan inverse of 0. So this will be 0. You can check. Tan inverse of 0, that will be 0. This one will be what? 3 over 2. This is 45 degrees, which is pi by 4. You can write this down like that. That will be 3 pi over 8. So basically, we know that this is the last part of the puzzle. This will be 3 pi over 8. So let me rewrite this down, everything together to see what we have. So let me write this here. So we have realized that f of x, sorry, the integration of 2, 0 f of x by dx have given you ln of 4 minus half ln of 2 and plus 3 pi over 8. I can combine these two together. If you observe, we have what? We have ln of 4. So what is ln of 4? It is ln of 2 power 2, which is 2 ln of 2. That will be 2 ln of 2 minus half ln of 2 plus 3 pi over 8. Now simplify. 2 minus half will be 3 over 2. Ln of 2 minus, so it will become plus, 3 pi over 8. So this will be your exact value for that integration. And that will be your question number 9, part B. Okay, so now let's move on to the last question of this paper. Question number 10. So here what do we have? Let's see. We have the diagram shows a curve of y. So this is your curve. Y is root x cos x. Okay, and for this domain is the x values between 0 and 3 over 2 pi. And it has a minimum point m, as you can see here. It has a minimum point. Now, where the value of x is equal to a. So, when x equal to a, it has a minimum point m. So m is a, and then we don't know what is y. Now, as you can see, we have a region that is shaded between the curve and the x-axis and denoted by the letter r. So part A, we have to show that A satisfies this equation. So as you can see, what happens at A? At A, we have the minimum point, and what happens at the minimum point? We know that at minimum point, dy by dx has to be 0. So let's do that. So y is given to you as root x cos x. Now as you can see, this is a product of two functions. So we have to use product rule to find dy by dx. So dy by dx is what? That will be, we leave the first one by itself, which is this, and multiply d by dx of this one will be minus sin x, then plus the second one by itself, and then d by dx of this one. If you observe, what is root of x? It is x power half. That will be first multiply by the power, and then minus half, and multiply by the, so here we have x of course, and then multiply by the d by dx of the inside value will be minus sin x. Let's simplify, that will give you what? That will be minus this sin x, will be minus sin x cos x over, so here we have half, that will be 2 here, and here we have, we can bring this down, that will become cos, the, where's the value here? Here we have, so, okay, this is not cos. That was a very dumb mistake, look at this. Because the value of v was not, it was not cos, is just x. So let me rewrite this again. That was a pretty dumb mistake. Let's do that. So basically, my idea was this is actually x power half. So d by dx of this will give you half multiplied by x power minus half, which is 1 over 2 root x. So this is not good here. This will have to go away. So this will give you, this will go away. This should be just 1 over root x2. Okay, so that was a mindless mistake. So that will be root of x sin x minus 1 over 2 root x. That is dy by dx. Now we know dy by dx is equal to 0 at the point x equal to a because that's the minimum point. So let's replace the values and see what happens. So you will have minus root of a sin of a. So here we have cos, we have forgot cos here, cos of x. So that'll be cos of a over 2 root of a is equal to 0. That's our main equation. So let me write this down in another page so we can be, we can have more space. So you know what, let me do this again for you because I think that was kind of confusing at first. So basically we have y given to you by root of x cos x. Now we know that at the point x equal to a, we have a minimum point. Now at minimum point, what do we know? We know that the gradient has to be 0. So we have to find dy by dx. So we know that this is going to be a product, so we have to use the product rule. So let's assume this is u and v. So dy by dx has to be u v prime plus v and u prime. So let's replace back in the equation. U is just the same thing, and this will be d by dx, and this will be minus sin x, and plus v is given by cos x, and u prime will be what? So pretty easy. The idea here is this can be written as x power half, so u prime will be half x power minus half. Simplify, you will have root x, so minus, of course, times sin x plus cos x over 2 root x. So here we have found dy by dx. Now we know that dy by dx is equal to 0. So this is 0 at x equal to a because it is a minimum point. So replace the value of x by a in that equation. Let's see what happens. We have minus sin of a plus cos of a over 2 root of a equal to 0. Now you want to eliminate the denominator, so you have to multiply everywhere by 2 root of a. So you will have what? Minus 2a sin of a plus cos of a. So as I've explained before, whenever you have cos and sine in the same equation, divide by cos of a everywhere. See what happens? You will have minus 2a, sine over cos will be tan, plus 1 equal to 0. So now you will have tan of a will be what value? That will be minus 1 over minus 2, which is, so this is 2a. So right now we can finally conclude that tan a has to be 1 over 2a. And this is shown as required for part 1 of the question. Okay, so now let's move on to part B. So definitely that was a mess at first. I hope that was more clear for this part A. Now part B, we have to use our formula here, okay, with the initial value of x equal to 3, and we have to find the value of a correct to 2 decimal place. So pretty easy. The first value has been given to you as 3, giving the result of each iteration to 4 decimal place. So x2 is what? So let's first begin with 3 is your answer, right? And then replace back in the formula, that will be pi plus tan inverse. So we have to make sure this is in radians. 1 divided by 2 answer. Okay, so let's begin. That will be 3 decimal place will be 3.3, so 4, so 6, 7. X power 3, so x3 will be 3.2917. x4 will be what? 3.2923. x5 3.2923, and x6 will be the same thing, 3.2923. So we conclude that the value of a has to be, the value correct to 2 decimal place will be 3.29 as your answer. This one is pretty simple to find the value of b. So value of a for part B. Now let's move on to part C of the question. So here we have to find the volume of the solid obtained when the region R is rotated completely about the x-axis. So now, when you have rotation about the x-axis, we have to know what formula to use. So volume about the x-axis will be pi integration of y squared by dx. We know y has been given to you by root x cos x. So from this, y squared will be what? Will be x cos square x. That's the first thing we can derive. So basically, we know that it will be integration for x cos x dx. Now, what is the limits of integration? We have to look at our graph. As you can see here, it is going to be between 0 and this value. So we have to find this value. Let's call it x. So our curve is given to you by y, and on the x-axis, we know that y is 0. So let's solve the equation. We have this, cos x has to be 0, because on the x-axis, y is 0. So first point is x has to be 0. This you know already, so we don't need that. We have to solve for this one. So x will be cos inverse of 0, that will be pi by 2, which is 90 degrees, that will be pi by 2. So the limits of integration will be 0 and pi by 2. That's something we need to know. Pi by 2 and 0. So now we can proceed with the integration. So now you can see we have cos square here. So we cannot, it is very hard to do that, so we have to break this down to see what can we use. Now just go back to your list of formula, you will see something here that we can use, which is, for this one, cos of double angle, you will have this equation that you can use. So let me write this down. So basically we know that cos square x is given to you by what? So let's write down the formula first, then we can make this become subject, so we have a better understanding. So cos 2a, this is given to you on the list, it is equal to 2 cos square a minus 1. This is given to you. Now let's make this become subject. You will have cos square a has to be cos 2a plus 1 divided by 2. Okay, this is given to you. Now we replace this back in the main equation. Let's see what happens. So right now you will have this over 2, 0, x multiplied by cos 2x plus 1 over 2 by dx. Now we can take out this value, so pi over 2, that will be pi over 2, 0. Now this multiplied by this will be x cos 2x and plus x by dx. Now again we can break this down into two parts. So pi over 2, that will be what? Let's see. Pi by 2, 0. That will be the first part by dx, and plus, let's put a bracket here, integration of pi by 2, 0, and x by dx for the other part. Now we can solve one by one, so we can make it easier for us. So first let's solve this one. So as you can see, this will become x squared over 2, limits of pi over 2, 0. That will be pi squared over 4 divided by 2. That will be pi squared over 8. So this will become pi squared over 8. Okay? Now how about this one? This one, as you can see, we have a algebra, and here we have a trigonometric expression. So we have to use integration by parts. Okay? So let me write this down again. So we have to find 0 x cos 2x dx. Now let's write down the formula that we have to use for that. I'm sure this is given to you on your list. Let me write this down. Okay, I can't seem to find it, but I know the formula, so let me write this down for you guys. Usually that will be integration of what? Of u du, that will be uv, integration of, that will be du by dx times v, and that will be by dx. That is the formula we have to use for integration by part. So now we have to choose which one is going to be u and which one is going to be v, also a dv. So here it is algebra, and here we have trigonometry. So we have to use the rule of Late. Okay, let's see which one comes first. So as you can see, here we have algebra, and here we have trigonometry. So A comes first, so if it comes first, we will choose this as u, and this will be chosen as dv. So let's write this down. U will be x, and dv will be the value of cos 2x. So now we have to find the value of du by dx, so du by dx has to be 1. So will be what? Integration of this, that will be sine 2x over 2. That will be v. So let's replace everything back into the formula. So this will give you uv is u is x, v is sine 2x over 2. Then we have to minus, minus here, not minus, root du by dx is 1, v is sine 2x over 2 by dx. So now we have to keep simplifying, so that will be x over 2 sine 2x minus, this will become minus cos 2x over 4. And the limits will be between pi by 2 and 0. So let's solve one by one. So here you will have what? Pi over 4 sine of pi minus become plus cos of pi over 4. And then here we have minus 0, that will be 0, become plus cos of 0 over 4. Let's see what are those values. Sine of pi will be what? 0. So this will be 0. Cos of pi will be minus 1. That will be minus 1 over 4. Here we have minus. That will be cos of 0 is 1. So minus 1 over 4. That will be minus half. Okay. So finally we have realized that this value here will be minus half. So in conclusion, I don't have much space anymore. Let me write this down here. In conclusion, we have realized that it will be pi by 2 will be outside, multiplied by, this was minus half, and then we have to plus the value of pi square over 8. That was, multiply inside, you will have minus pi over 4 plus pi cube over 16. Okay, so that will be your answer for question number 10 part C.